All right, welcome back again. This is video number 3, and as previously promised, now we're going to do a little math. We're going to talk about the pH scale that you've probably heard of before, and what the heck those numbers actually mean. Now, in elementary or junior high, you might have done something with litmus paper. Litmus paper contains a compound that changes color depending on the pH of the solution it's in. It'll actually react with that acid or base, and that reaction results in a color change. So you can use it to gauge how strong an acid or a base is. Here's an example of the pH scale. You'll see that it runs from 0 to 14. It's a measure of the concentration of hydrogen ions. You'll also see in my picture there's a pOH scale, which is the inverse. But the really important thing to note about the pH scale is that it is logarithmic, which means every change of 1 on the pH scale is a change by a factor of 10 in the concentration. So something with a pH of 1 is 10 times stronger than something with a pH of 2. 2 is 10 times stronger than 3, and so forth. So when we look at our scale here, we set it around water. Straight H2O has a pH of 7, and we call that neutral. Looking on either side of it, your blood is just a little bit basic, around 7.5, whereas urine will have a variance depending on how hydrated you are, but that uric acid will make it a little acidic. Moving down the acidic side, tomatoes, oranges, also you could put in there things like grapefruits and lemons and limes are all pretty acidic. Your cola drinks, things like Coke, Pepsi, root beer, are fairly acidic. Not quite so much though as when we say gastric juices, we really mean mostly stomach acid. And then all the way down at a pH of 0 would be a strong acid with a concentration of 1 molar. Looking at the basic side, baking soda is a little bit basic. Seawater is fairly basic. Then milk of magnesia is something you might take when you're sick. Pretty basic. Household ammonia, a cleaning agent, is very basic. But we slide all the way up to 1 molar of a strong base like sodium hydroxide, having a pH of 14. We typically think of the pH scale going from 0 to 14. You actually can go a little bit negative or a little bit above 14 with some very, very concentrated strong acids and bases. So here's where these numbers actually come from. pH is the negative log of the H plus concentration. Now, it's the first time we've seen this notation. When we put brackets around an ion or a compound, we mean its concentration. That's what brackets mean. So negative log of H plus concentration is pH. The negative log of the OH minus concentration is the pOH. Now, the important thing to remember about these is that H plus and OH minus are going to be inverses of each other. So when we add the pH and the pOH, we'll always get 14. If the pH is 2, the pOH is 12. And similarly with any other numbers. Our H plus concentration then, using just a little bit of math that hopefully you've learned already, would be 10 to the negative pH. And our OH minus concentration similarly is 10 to the negative pOH. This also means that if you multiply OH minus and H plus, you will always get 10 to the negative 14th. So we have 6 equations here, but really it's 2 versions of the same equations, and then our ones in pink tagged onto it that are the sum of the 2. pH is negative log of H plus, pOH is negative log of OH minus, which means H plus is 10 to the negative pH, OH minus is 10 to the negative pOH. pH plus pOH is always 14. OH minus times H plus is always 10 to the minus 14th. With this series of equations, if you know one of these values, H plus, OH minus, pH, or pOH, you can always find the other 3. It just might take you a couple steps. So let's practice that. To find the pH of a solution with an H plus concentration of 0.5 molar, we would say pH is equal to negative log of H plus, so negative log of 0.5. You plug that into your calculator and you get 0.3. Let's do another. Remembering that pH is negative log of H plus, what's the pH of a solution with a concentration of 0.1 molar? So then we do the negative log of 0.1 and we get 1. Let's try a different equation now. Remember, pH plus pOH is always 14. That means if the pH is 3.5, the pOH is 14 minus 3.5, or 10.5. Since pH is negative log of H plus is 10 to the negative pH. So if we know the pH is 3.25, the H plus is 10 to the negative 3.25, or 5.6 times 10 to the minus 4th molar. Another addition one, if pH is 4.25, pOH is 14 minus 4.25, or 9 3/4. Now getting a little more sophisticated, let's put two equations together. Let's find the H plus concentration if the pOH is 7.25. Well, if the pOH is 7.25, you know the pH is 14 minus that, or 6.75. And then H plus is 10 to the minus pH, so H plus is 10 to the minus 6.75, which is 1.8 times 10 to the minus 7th molar. As you can see here, we can always just work our way around the circle. Since we found the H plus concentration, we could use that to find the OH minus concentration, or you could have just used the initial pOH to find the OH minus. Once you know one value, you can always find the other three. This was a pretty brief run through of acid-base calculations. You'll have some practice in your homework as well. As always, make sure that you contact me with any questions you have. Please don't be intimidated by the presence of some exponents and some logarithms. They're buttons you hit on the calculator. You're going to be just fine. Next time, we'll talk about doing some reactions now that we understand where these numbers come from, as well as a pretty cool laboratory technique that hopefully we get a chance to practice.